Alright, today let's have a look at topic 7, graphing lines. First of all, let's have a look at the concept of the distance between 2 points in 1D space. So here 1D space means one-dimensional space. Usually we'll use the number axis. We'll use number axis to denote the one-dimensional case, because in one-dimensional space you can only move along one direction, right? So distance between 2 points means, suppose you have a point here A and another point here B, and A has coordinate x1 and B has coordinate x2. Then the distance between A and B, which is denoted by this symbol here, equals the absolute value of the distance between x1 and x2. Or you could also write it like x2 minus x1. Doesn't matter, because we're trying to find this absolute value. So this is the distance between A and B. Did you get it? So we'll just use the absolute value of x1 minus x2 here. And also note that if x1 is greater than or equal to x2, which means x1 minus x2 is greater than or equal to 0, then we have the absolute value of x1 minus x2 equals x1 minus x2 itself, right? Otherwise, if x1 is less than or equal to x2, which means x1 minus x2 is less than or equal to 0, then the absolute value of x1 minus x2 equals the opposite number, which is negative x1 minus x2, and this is x2 minus x1, right? Any questions? So let's make a summary here. This tells us that if there are 2 points A, B, whose coordinates are x1 and x2 respectively, then the distance between A and B, which is denoted by AB here, is calculated by the absolute value of the difference between the 2 coordinates, x1 and x2. You get it? And also note that you can simplify, you can remove the absolute value signs according to whether x1 is greater than or equal to x2 or x1 is less than or equal to x2. You can remove the absolute value signs accordingly. Did you get it? For example, if we have 2 points, -5 and 9, we know, well, let's call this point A, this point B. We know the distance between A and B is given by the absolute value of -5 minus 9, right? Which is 14. Any questions? The y-dimensional case is actually very basic, very easy, right? And let's have a look at another concept, which is the midpoint of 2 points in 1D space. Which means if there are 2 points A and B in the one-dimensional space, and their coordinates are x1 and x2 respectively, then we can find the midpoint between A and B. So let's suppose this point is M, which means this distance between A and M should be equal to the distance between B and M, right? So we don't know the coordinates of M yet, so let's call this xm. And then we know that xm minus x1, that's the distance between A and M, right? And of course, M is greater than or equal to 1, so we can just remove the absolute values here. Just remove the absolute value signs there. And that distance should equal to this distance here, which is x2 minus xm, right? Again, x2 is greater than or equal to xm, so we don't use, you can just ignore the absolute value signs. Therefore, we have 2xm equals x1 plus x2, right? Then we can solve the coordinate of the midpoint xm is half of the sum of x1 and x2. Do you get it? So to summarize, if there are 2 points A whose coordinate is x1 and B whose coordinate is x2, then the point M whose coordinate is xm, which is the midpoint of A and B, then the coordinate of point M is calculated in this way. xm equals 1/2 of sum of x1 and x2. Do you get it? Any questions?
No.
Alright, then let's see an example here. So what number is midway between -3 and 9 on the number line? So apparently this question asks you to find the midpoint between these 2 points in 1D space, right? So we can just directly use the midpoint formula. So the point in the middle is 1/2 of -3 plus 9, which is 1/2 times 6, and this gives us 3, right? Therefore, we know the midpoint in the one-dimensional space has coordinates 3. Of course, you can also verify this by yourself. Distance between -3 and 3 is 6, right? And we also know distance between 9 and 6 is also 6. Therefore, 6 is the midpoint. Did you get it? Alright, if you don't have any questions, let's have a look at another concept. Next, let's have a look at the cases in two-dimensional space, which is abbreviated as 2D space. First, let's have a look at distance between 2 points in 2D space. So in 2D space, we have x coordinate, x axis and y axis, right? Suppose we have 2 points A and B. So coordinates of A are x1, y1. Coordinates of B are x2, y2. Well, first of all, let's suppose x1 does not equal x2 and y1 does not equal y2, which means the line AB is not parallel to x-axis or y-axis, right? So the distance between these 2 points, again, we use this sign to denote the distance between the 2 points, is given by a formula. So what the formula is? This formula makes we can use Pythagorean's theorem to help us to find the distance between A and B, right? So we can draw a perpendicular line to x-axis that passes through A, and draw a parallel line to x-axis that passes through A, draw a parallel line that passes through B, which is parallel to y-axis, and let's call this point C. Then we know the distance between AB is square root of AC squared plus BC squared, right? So how do we calculate distance between A and C? This is actually a one-dimensional case, right? Because line AC is parallel to the x-axis. And we can also easily know that x-coordinate of C equals x-coordinate of B, which is x2. Y-coordinate of C equals y-coordinate of A, which is y1, right? And then we know the distance between A and C should equal the difference between their x coordinates, x1 minus x2. And we use absolute value here, right? This is distance between A and C. And distance between B and C, again, this is a one-dimensional case because BC is just parallel to y-axis. So the distance between B and C is the absolute value of y1 minus y2, right? Therefore, we know the absolute value of, the distance between A and B equals AC squared, which is the absolute value of x1 minus x2 squared, and actually we can then remove the absolute value signs. So absolute value squared is just x minus x1 minus x2 squared, right? Plus, again, same method, plus 1 y1 minus y2 squared. Did you get it? So that's the distance between A and B, which is the square root of a sum of the difference of x coordinate squared plus difference between the y coordinate squared. Did you get it? Okay, so to summarize, if there are 2 points A and B whose coordinates are x1, y1 and x2, y2 respectively in the two-dimensional space, then the distance between A and B, which is denoted by this sign, this symbol here, is given by this formula, the square root of x1 minus x2 squared plus y1 minus y2 squared.
Yes. No.
So next, let's have a look at an example. You can find the distance between the 2 points, which is -3 and -5, and 5, 1. And according to the distance between the 2 points in 2D space, we know the distance between these 2 points should be the square root of x1 minus x2 squared, right? Plus y1 minus y2 squared. So that's the distance between the 2 points. Then that is 64 plus 36, which gives us square root of 100, and that's actually 10, right? So the distance between these 2 points is 10. Very good. Okay, and if you finish, next let's have a look at the midpoint between 2 points in two-dimensional space. So previously we have talked about midpoint of the 2 points in one-dimensional space, right? Well, you can actually use similar methods to find the midpoint of any 2 points in the 2D space. Oh, sorry about that. Actually, I forgot to talk about a special case here. So in our discussion here, we assume x1 is not x2 and y1 is not y2, right? And actually, if x1 equals x2, that means if A is here, B must be here, right? In that case, the distance between A and B is actually the absolute value of y1 minus y2, right? And here x1 minus x2 is 0. So if you use this formula to calculate that, then the first term is actually 0. And the square root of y1 minus y2 squared actually equals the absolute value of y1 minus y2. So this formula is also correct when x1 equals x2. And you can use the same method to verify that this formula is also correct for the cases where y1 equals y2. So no matter what the 2 points are, where the 2 points are, this formula to calculate distance between the 2 points is always correct in the 2-dimensional space. Did you get it? Okay, next let's have a look at the cases where the midpoint of 2 points in 2-dimensional space. Well, actually, let's suppose there are 2 points here. Then the midpoint is M, whose coordinates are xm and ym. Then the method to calculate x and ym is the same in the 1-dimensional space. Because if you draw two perpendicular lines like this, and we know that in the x direction, xm must be the midpoint of x1 and x2, right? Therefore, we know xm is 1/2 of x1 plus x2. On the other direction, along the y direction, we know ym must be in the middle of y1 and y2, right? So ym equals 1/2 times y1 plus y2. Do you get it? So in a summary, if there are 2 points A and B, whose coordinates are x1, y1, x2, y2, and point M, whose coordinate is xm, ym, it's the midpoint of A and B, then we can calculate the coordinates of point M, where xm is 1/2 of x1 plus x2, and ym, the y coordinate of M, is given by 1/2 of the sum of y1 plus y2. You get it? Okay, so have a look at these and let me know if you finish, okay? Alright, if you finish, next let's have a look at the graphs and main properties of lines in 2-dimensional space. Okay, first let's have a look at some concepts related to lines. The first concept is the slope of line in 2D space. The slope of line in the plane containing the x and y axis is generally represented by the letter M. Well, sometimes we could also use the letter K, doesn't matter. Usually we'll use letter M to denote the slope. And that is defined as a change in the y coordinate divided by the corresponding change in the x coordinate between two distinct points on the line. This is described by the following equation. So, assuming 2 points are A and B whose coordinates are x1, y1, and x2, y2, then according to the definition, the slope of that line, okay, suppose this is A, this is B, then the slope of that line is defined as delta y over delta x. That is by definition. Which means the change in the y direction per unit of the change in the x direction, where x1 does not equal x2. And okay, sorry, there is a typo here. Well, actually, if x1 equals x2, in that case, line AB must be perpendicular to the x-axis, right? So we don't care about the position of y-axis as long as x1 equals x2. We have AB is perpendicular to x, or AB is parallel to y-axis, right? In that case, we have delta x equals 0. We don't have 0 as denominator, right? Therefore, in that case, the line is parallel to y-axis and its slope is undefined because we cannot have 0 as denominator. Do you get it? This is a concept of slope of a line in two-dimensional space. And of course, depending on how the line looks like, there are different cases for our slope here. For example, the first case is if a line is increasing, then it goes up from left to right. In that case, the slope is positive. So basically, if you have a 2D coordinate like this, and a line in that direction from left to right, then the slope of the line is positive. Why? Because according to the definition, we know that slope is defined as delta y over delta x, right? For example, suppose A has coordinates x1, y1, B has coordinates x2, y2. If the line in this direction, that means if x2 is larger than x1, then y2 must be larger than y1, right? Therefore, both x2 minus x1 and y2 minus y1 should be both positive or both negative. They have the same sign in front of them, right? Therefore, we have delta y over delta x is always positive, right? And also note that in that case, delta y over delta x is actually tangent theta here. And theta is an angle whose initial arm is the x-axis, terminal arm is the line AB. So have a look at the diagram here. Any questions, just let me know, okay? So in a summary, a line is increasing if it goes up from left to right. Then in that case, the slope is positive. which means m is greater than 0. So in this case, the slope m equals delta y over delta x, which also equals tangent theta, and the slope is positive. Okay, if you finish, of course, this is just one of the cases there. We could also have a line in that direction, right? So if in that case, line is decreasing. Line is decreasing if it goes down from left to right. In that case, the slope is negative. So why is that? Because according to the definition, slope m equals delta y over delta x, right? If the line goes down from left to right, that means if y2 minus y1 is less than 0, then x2 minus x1 must be greater than 0. Or if y2 minus y1 is greater than 0, then y2 minus x2 minus x1 must be less than 0. They always have opposite signs, right? Which means as x increases, y decreases, or as x decreases, y increases. Therefore, delta y over delta x is always a negative number, right? And according to the diagram here, we know that tangent theta here, theta is this angle here, tangent theta equals the absolute value of y2 minus y1 over x2 minus x1. So in that case, tangent theta, because theta is acute angle, tangent theta is always positive. So here, in that case, the slope of that line, if you want to use theta to evaluate the slope of that line, then you should use negative tangent theta, right? Not positive tangent theta, but negative tangent theta here. Okay, and in a summary, line is decreasing if it goes down from left to right. Then in that case, the slope is negative, which means m is less than 0. M equals delta y over delta x, which equals negative tangent theta. Theta is this angle here, which is less than 0. Okay, so of course there might be a third case, right? So in either of the first case or the second case, x and y are not equal, or y and x are not equal, right? So in the third case, this is a special case. We could have a line that is horizontal, right? Which means y1 equals y2, right? In that case, if a line is horizontal, then we know the slope is 0. Because in that case, delta y is always 0, right? 0 over a non-zero number, which gives us a 0. So in that case, horizontal line has slope 0. And this is actually a constant function, because no matter what x is, the output y is always a constant number, right? For example, if this point is 2, then this line has the equation y equals 2. It's actually a constant function. Any questions?
What if the line is vertical?
Alright, so let's have a look at the last case. If the line is vertical, that means delta x is 0, right? And in that case, we have 0 as a denominator. So the ratio is not defined when the denominator is 0. So in a summary, if we have a vertical line, a line is vertical, or a line is parallel to y-axis, or a line is perpendicular to x-axis, in that case, the slope of that line, m, is not defined, or m is undefined. Did you get it? Okay, so next, let's make a summary of the 4 cases we have just talked about. So suppose we have a 2D Cartesian plane like this, and well, suppose the line crosses the origin point. When the line is parallel to x-axis, we know m equals 0, right? So as we turn the line counterclockwise like this, then the slope of this line is increasing from 0 and then all the way to positive infinity, right? And when the line is vertical, or when the line is perpendicular to x-axis here, m is undefined. And when this angle here is 45 degrees, we have m equals 1, right? So anything in between here, we have m is greater than or equal to 0 and less than 1. And anything in between here, we have m is larger than 1, less than positive infinity. You get it? And once the line is here, when this angle is 45 degrees, we have m equals -1, right? Because tangent 45 degrees is 1, negative tangent 45 degrees is -1. And if a line is in between of this area, we know that m is smaller than -1, larger than -infinity, right? And when the line is here in this region, we know the slope of this line is increasing from -1 all the way back to 0, right? So in this region, m is greater than -1, less than or equal to 0. Well, actually, we should not write equals here. So in this region, m is greater than -1 and less than 0, right? Did you get it? Do you have any questions here?
No.
All right, good. So next, let's have a look at a practice, okay? So given the graph on the right, can you fill in the following blanks with appropriate letters A, B, C, D, E, and F, representing different lines on the graph? Okay, so we have a 2D Carson plane here, and suppose the the length of the side of the squares is 1. So that's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. -1, -2, -3, -4, -5, -6. -1, -2, 3, 4, 5, 6. Okay, so if you finish, please give me your answer in the chat box. All right.
Yes, I did. Okay.
All right, let's have a look at the solution together. Which line has slope equals 1? Line B has slope equals 1, right? Because we know that delta y equals delta x in line B. Therefore, line B has a slope 1, right? Which line has slope that is greater than 1? So anything in that region, any line in that region has slope greater than 1, right? So C is here. And which line has slope between 0 and 1? We know any line in this region has slope between 0 and 1. Because in that case, your delta y is always less than delta x, and both of them are positive, right? So A is here. And this line here has slope -1, so we put letter E here. And line D has slope that is less than -1. And line F has a slope between -1 and 0. You get it? All right. If no questions, let's have a look at the next concept. All right. Next, this concept of intercepts of a line in 2D space. There are two types of intercepts: x-intercepts and y-intercepts. First of all, the intersection point between the given line and the y-axis is called the y-intercept, usually denoted as 0b. And if the equation of the line is given, we can let x equals 0 and solve for y to find the value of b, right? For example, if we have a line like this, then according to the definition, the point of intersection between that line and the y-intercept, which is here, this point, whose coordinates are 0b, because the x-coordinate of that point must be 0, right? So this point is called y-intercept. So actually the y-intercept is a point, right? So technically speaking, strictly speaking, you should give both x and y coordinates of the y-intercept. But in some textbooks, it's also fine to just give the y coordinate, because we know that for y-intercept, the x coordinate must be 0, right? So you could either say the y-intercept is 0b, or you could also say the y-intercept is just b. Both are okay. And also, if the line is parallel to y-axis, then the y-intercept does not exist, because in that case, the line does not intersect with the y-axis, right? Except the case that the line is the y-axis itself. In that case, there are unlimited number of y-axes. And actually, in that case, this is not a function, because for one input x equals 0, you might have different outputs, right? So we really don't care about that. That's a special case. And the x-intercept is defined as the point of intersection between the given line and the x-axis, which is this point here. And usually we use a0 to denote the x-intercept. Again, you could either say the x-intercept is a0, or you could also say the x-intercept is a number a, because for x-intercept, the y-coordinate is always 0, right? And in order to, if you know the equation of that line, you could let y equals 0 and solve for x to find the value of a, right? And also note that if the line is parallel to x-axis, then the x-intercept does not exist, except the line's x-axis itself. In that case, you might have infinite number of x-axis, x-intercepts. Did you get it? So in a summary, the y-intercept is just a point of intersection between the line and the y-axis, and the x-intercept is the point of intersection between the line and the x-axis, right? Any questions? Okay, if no questions, let's have a look at the next topic, which is the equation of a line in 2D space. So first of all, there are different types of equations for a line. So first of all, let's have a look at the point-slope form of the equation of a line, which means suppose you know one point on the line, which is x naught, y naught, and we also know the slope of that line is m. Then how could you express the set of point that is on the line? So any point on the line must satisfy the equation of that line, right? For any point on the line, suppose we choose any arbitrary point and let this point be x, y, then we could establish the relationship between x and y using the slope, right? Because any point that is on the line has the same slope with respect to the given point x naught, y naught, right? So y minus y0 over x minus x0 or x naught must be always equal to the constant number m for any arbitrary point on that line, right? So note that the coordinates x, y is the coordinates of any arbitrary point on that line. Therefore, we always have this relationship. Did you get it? And you can multiply both sides using x minus x naught. So this gives us y minus y naught equals m times x minus x naught. And this is actually called the point-slope form, which means if you know a point on the line and the slope of that line, you could express the equation of that line in this form. This is called point-slope form. So why we could multiply both sides using x minus x naught? Because once you know the slope is m, that means slope exists, right? If the slope exists, x minus x naught cannot be 0. Therefore, these two expressions are equivalent. Well, usually we'll use the second one to denote the point slope form. All right? For example, well, if you know a line crosses a point 1, 2 with a slope 1/2, then we could write the equation of this line in this way. Y minus the given y coordinate equals slope times x minus the given x coordinate. And of course, you could also simplify this to y equals 1/2 of x minus 1 over 2 plus 2, which is y equals 1 over 2x, then plus 3 over 2, right? Of course, you could also keep it in this way. Did you get it? So have a look at the equation here. This is called the point slope form of a line in 2D space. Alright, if we have finished, note that the point slope form is y minus y naught equals m times x minus x naught, right? So if we move y naught to the other side, we have y equals mx minus mx naught plus y naught. So m is known, which is a constant number. X naught, y naught are also constant numbers. So if we denote this number here as another number b, then this equation is actually y equals mx plus b, right? And this is also an equation of this line, and we call this form of equation is slope-intercept form, because we know this is the slope of that line, right? And b is the y-intercept. Y is a y-intercept because if you let x equal 0, then the number you find is a y-intercept, right? If you let x equal 0, y equals b, therefore b is the y-intercept. So in this equation, we can locate both of the slope and y-intercept. Therefore, if you have a form like this, form of equation like this is called the slope-intercept form of a line in 2D space. For example, in our previous example here, this is a point slope form, right? And if you simplify that to this equation here, then this equation is called the slope-intercept form. First number here is the slope of that line, and the constant number here is the y-intercept of that line. Did you get it? Okay, for example, y equals 1 over 2x plus 4. And this is called the slope of that line. And this is called the y-intercept of that line. Alright, if you have finished, next let's consider another problem. The line can also be expressed in two-intercept form. So what does this mean? This means if, let's consider this problem, if the x-intercept of a line is a0 and the y-intercept of that line is 0b, and of course here a is not 0 and b is not 0. Can you write the equation of that line? So we have already learned the point slope form and slope intercept form, right? So first of all, we could find the slope of that line. The slope of that line is delta y over delta x, so we could use b minus 0 over 0 minus a, which is negative b over a, right? This is the slope of that line. And of course, we have already know that the line passes through a point a0. We know this point, therefore we could use the point slope form to express that line, right? Which is y minus y naught, the given point, equals slope negative b over a times x minus x naught, the given x coordinate of that point. And then let's simplify this a little bit. That's y equals negative b over a times x plus b, right? Then we can multiply both sides using a. That gives us a y. Well, at the same time, move the negative b to the left side. That gives us plus bx equals ab, right? And then we could divide both sides using ab because a is not 0, b is not 0. Therefore, the product of ab is not 0. And this is equivalent to ay over ab plus bx over ab equals 1, right? And eventually we get an equation like this. X over a plus y over b equals 1. And this is actually called the two-intercept form. X over the x-intercept a plus y over the y-intercept b equals 1. If you know the x and y-intercept of that line, you could directly write the equation of that line using the two-intercept form. Do you get it? So have a look at the two-intercept form here, and let me know if you have any questions. All right. Okay, and actually if we put all these together, we have the general form of a line. Any line in the 2D Cartesian plane can be expressed in an equation with the general form, which is ax plus by equals c, where a, b, and c are constants, and a and b are not both 0. Okay, be careful with the constraints here. And from the general form, we can easily find the slope-intercept form, right? As long as you divide both sides using b, then you will have a over bx plus y equals c over b. Then y equals negative a over bx plus c over b. Then this is a slope, this is a y-intercept, right? And any special line, for example, the line that is parallel to x-axis can also be expressed using this equation, because in that case, we know that line should be, there is no x there, right? In that case, a equals 0. We simply have by equals c, which is y equals c over b, right? And you can also use this equation to express a line that is parallel to y-axis. In that case, this term does not exist. We simply have x equals c over a, right? So this is called the general form of a line. Any line in the 2D Cartesian plane can be expressed in this form. And if you have a linear equation like this, the graph of that equation is also a line. Or in other words, this linear equation describes the relationship between the x and y. Any point x, y that satisfies this relationship or equation is on the same line, which is expressed by this equation. This is called general form of line. All right, any questions? Well, if not,
No.
let's have a look at example here. He write the equation of a line that passes through the point and has slope -1/4, and then sketch its graph. Okay, I'll lead you through these questions. So if we know a point and if we know the slope, it's better to use the point slope form to write this line, right? So that line is y minus the given y coordinate equals slope -1/4 times x minus the given x coordinate, right? So this is the equation of that line. So let's simplify this a little bit. -1/4 x and -3/4, right? So y equals -1/4 of x, then 1 minus 3/4 is plus 1/4, right? So the slope is -1/4 and y-intercept is +1/4. And sketch this graph. Usually, if you want to sketch a graph, as long as you can find its x and y-intercept and connect these 2 points, will then give a sketch of that graph, right? So first of all, we know x equals 0. When x equals 0, y equals 1/4. And when y equals 0, we have x equals 1, right? Therefore, it crosses a point 0, 1/4, and 1, 0, which is here. So let's connect these 2 points, and that graph is the line y equals -1/4 x plus 1/4, right? This is a sketch of that line. Did you get it? Usually, you'll need to label the x and y intercept. Any questions? Okay, if no questions, let's consider another example. Line with slope 3 intersects a line with slope 5 at the point 10, 15. What is the distance between the x-intercepts of these two lines? When you finish, please give me your answer in chat box, okay? Have you finished? Any ideas? Okay, so we know the first line has slope 3 and it passes through this point, right? Second line has slope 5, also passes through this point because it says the intersect at this point. So both of them shall pass through this point, right? So for line L1, we know slope is 3 and we know a point, so it's better to express that line in point slope form. So that line is y minus 15 equals slope times x minus 10, right? Which is equivalent to y equals 3x minus 30 plus 15. That's minus 15. That's our first line. Second line is y minus 15 equals 5 times x minus 10, right? And can be simplified to y equals 5x minus 50 plus 15. So that is negative 35, right? And question asks to find the x-intercept of these two lines. So let's find the x-intercept of them. For the first one, the if you want to find the x-intercept, you should let y equals 0, right? If y equals 0, we have x equals 5. And for the second line, again, we could let y equals 0. If y equals 0, we know x equals 7, right? And then we know the x-intercept of L1 is the point 5, 0. The x-intercept of line L2 is the point 7, 0. Of course, we know the distance between these two x-intercepts is just the 7 minus 5, which is 2, right? You get it?
Excuse me. So the equation over here, the y in the equation is the y-intercept, right? So the y in this equation is the y-intercept, right? Okay. Okay. Understand.
Then next, the method to find the point of intersection between two lines in the two-dimensional space. So sometimes we want to find, well, if two lines intersect at a certain point, we want to find the coordinate of that point, right? So how we can do this? Well, note that if we let the coordinate of that intersection point be x and y, then we know that this point should satisfy both equations of line L1 and line L2, right? Because it's on line L1 and it's also on line L2. So it should satisfy both of their equations, right? So this is how we can find the point of intersections. If the first line has the equation a1x plus b1y plus c1, of course, here a1, b1, c1 are constants. And a second line has equation a2x, b2y equals c2. Again, a2, b2, c2 are constants. X and y are variables, which means the x and y coordinate of any point on the line. All right? So they are variables, and a, b, c are constants. Then the intersection, if it exists, of these two lines is the solution of the following system. We simply combine these two equations. If you can solve this system of linear equations, then you could find the point of intersection. Otherwise, if you can't find any solution, that means the two lines do not intersect in the 2D space. They could be either the same line on top of each other, or they could also be parallel with each other. Did you get it? So let's have a look at an example. Suppose we have line L1. Well, let's just write some arbitrary lines there. 3x plus 2y, 2x plus 3y equals 4. And line 2, which is x plus 2y equals -1. Can you find any point of intersection between these two lines? Or do they intersect? Well, the point of intersection, if it exists, it must satisfy both of the two equations, right? So we need to solve this system to see if we can find any solutions. So we call them number 1 and number 2. And we have already know how to solve this system of such equations like this, right? So from equation number 2, we could use either a substitution method or elimination method. So for example, from equation number 2, we can have x equals -2y minus 1. And let's call this number 3. Then we could put number 3 into equation number 1, right? This gives us 2x, which means 2 times -2y minus 1, plus 3y equals 4. And this gives us -4y minus 2 plus 3y equals 4, right? And this simply means y equals -6. Then let's put equation number 4 back into equation number 3. Then x equals -2 times -6 minus 1, and x equals 11, right? Therefore, we can find a unique pair of solution, which is x equals 11 and y equals -6. which means we have a unique point of intersection. These two lines must intersect at the point 11, -6. Did you get it?
Now,
Alright, good. If no questions, let's have a look at the last two topics. Parallel lines in 2D space. Well, sometimes we have, in the 2D space, we could have two parallel lines, right? And actually two lines are parallel if and only if, first, both of their slopes do not exist. In that case, they are both parallel to the y-axis. If both of their slopes do not exist, we know that these two lines must be parallel, right? Or it could also be the case in which both of their slopes exist and their slopes are equal, which means you could have a line here, another line here, right? So here I'll just give you an intuitive explanation here. And after this class, it's better for you to prove it rigorously using mathematical reasoning, okay? So why two lines are parallel if and only if their slope exists? If and only if their slopes are equal. If their slope exists. Because, first of all, if two lines are parallel, then we know that this angle must equal this angle here, right? And actually, we can use this angle to calculate the slope of each line. For this line, the slope of that line is tangent theta. And for the second line, because this angle is still theta, so the slope is also tangent theta. Therefore, as you can see here, their slopes are actually equal, right? That means if the two lines are parallel, their slopes are equal. We have proved this direction. And you need to also prove this direction, which means if their slopes are equal, then they are parallel. Well, intuitively speaking, if their slopes are equal, then these two angles should be the same, right? Because we could express their slopes using these angles. So if these two angles are the same, that means corresponding angles are the same, so this line must be parallel with this line in geometry, right? Again, this is just an intuitive explanation, and you need to prove this rigorously in mathematical reasoning. So try to do this after this class, alright? So this is how we can determine if two lines are parallel or not. Just check if their slopes are equal or not. If the slopes exist. Otherwise, if their slopes do not exist, we know that must be equal. There must be parallel, right? Did you get it? And perpendicular lines. Sometimes you could also have perpendicular lines in 2D space, right? Two lines are perpendicular if and only if A, one line is parallel to x-axis and the other is parallel to y-axis. Of course, we know in that case that two lines must be parallel, right? Must be perpendicular, right? And there is another case. Both of their slopes exist. and their product of their slopes is -1. Again, here I'll just give you a intuitive explanation. Try to prove this by yourself after class, okay? So first of all, two lines are perpendicular. That means this angle here must be 90 degrees, right? So if we call this angle here is theta, then this angle here is half pi minus theta, right? Therefore, for line 1, the slope is tangent theta. For line 2, the slope is negative tangent half pi minus theta, which equals, according to the co-function identity, that's actually negative cotangent theta. And we know that the product of cotangent and tangent equals 1, but we have a negative symbol in front. Therefore, the product of the two slopes equals 1, -1, right? And that proves this direction here. If the two lines are perpendicular, then we have the product of their slope is -1. And also, we could use similar method to prove this direction. If the product of their slope is -1, that means suppose this angle here is theta, then the slope of L1 is tangent theta. And if you know their slope, the product of their slope is -1, then we could express the slope of L2 to negative cotangent theta. And we could also express negative cotangent theta to negative tangent half pi minus theta. Therefore, we know this angle here could be expressed using half pi minus theta, right? Therefore, if this angle can be expressed using half pi minus theta, and this angle can be expressed using theta, then we know that the sum of these two angles must equal half pi. Therefore, this angle here should be half pi, and then we know the two lines are perpendicular. Well, actually, if you learn the concept of trigonometry or vectors, it's much easier to prove that in vectors, using vectors. So try using different method to prove this rigorously after this class, okay? If you have any questions, just send me a message. I'll explain this to you in detail. All right, so just remember that if two lines are parallel, that's equivalent to say either their slopes do not exist, or both of their slopes exist and their slopes are equal. And if two lines are perpendicular, that's equivalent to say one line is parallel to x-axis and the other is parallel to y-axis, or both of their slopes exist and the product of their slopes is -1. So these are the methods we can use to check whether the two lines are parallel or perpendicular. Did you get it? So at the end of this class, let's consider an example here. First of all, can you find an equation of the lines through the point 2, 1, and it's parallel to the graph of 2x minus 7y equals 4. Second, what is the x-intercept of the lines through this point, -3, 4? That is perpendicular to the graph of x minus 2y equals 7. Okay, because we're running out of time, so I'll lead you through these two questions. For the first question, we know that this line has a slope, right? If this line has a slope and is parallel to the other line, that means the other line has the same slope as this line, right? So let's say the slope L1 has the equation 2x minus 7 equals 4. First of all, let's find a slope. So this can be rewritten as 7y equals 2x minus 4, and y equals 2 over 7x minus 7 minus 4 over 7, right? Therefore, we know the slope is 2 over 7. So let's suppose L2 has the same slope because it's parallel to this line, right? It must have the same slope. Therefore, the equation of L2 must be y equals 2 over 7x plus some y-intercept, which we don't know yet, so let's call it b. And we know that line passed through the point 2, 1. Therefore, 1x equals 2, y equals 1. And this gives us 1 equals 2 over 7 times 2 plus b. And therefore, we can solve. b is actually 3 over 7. Therefore, we can solve. L2 has the equation y equals 2 over 7x plus the y-intercept 3 over 7, right? You get it? As to the second question, the method should be the same, but this time we know L1 has the equation x minus 2y equals 7, which is equivalent to 2y equals x minus 7. And let's find the intercept. So divide both sides using 2, y equals 1 over 2x minus 7 over 2. So this is our slope. Slope is 1 over 2, right? And we know L2 is perpendicular to this line, and that means the product of the slope of line L2 with the slope of line L1 equals -1. Therefore, L2 should have the slope -2. So L2 has this equation here. Y equals -2x plus the y-intercept b, right? And we know that line passes through -3 and 4. That means when x equals -3, y equals 4. And this tells us that 4 equals -2 times -3 plus b. Of course, we can solve b equals -2, right? Therefore, we know line L2 has the equation -2x minus b. You get it? Now, do you have any questions? Alright, in that case, class is over for today. Remember to complete your homework and submit before the deadline, okay? I'll see you next time. Bye.
Bye.
Bye.